In this next segment of our labor demand elasticity module, I'd like to take a look at the own wage elasticity and the cross wage elasticity, not only in terms of identifying what those terms mean, but what they will really represent to us as we think about elasticity of demand in the labor market. So let's think about this. The own wage elasticity is going to be what change might we expect to see in the quantity of labor demanded for a particular type of worker when wages for that same type of worker changes. So let's think about this first in terms of a labor market model. We're going to look very briefly at the simplified, just the demand side of the model. We have wage and labor. We have some downward sloping labor demand curve. And we might go from wage level 1, some wage level 1, to, and some labor level 1, to some wage level 2, and some labor level 2. Well, what kind of a demand elasticity would we see here? Let's assume for a moment that we had a labor demand equation of LD equals 60 minus 3W. So I don't know, will this be elastic or will it be inelastic? But what I know is that we're looking for at a particular type of worker, worker I, and the wage for that same type of worker. So let's say that this is just some kind of worker, so model for general workers, but they're all the same type. So if we go from, let's say, wage 1, let's assume that wage 1 is 10, wage 1 equals 10. And we now want to then think about going to wage 2, and let's say that's wage 2 is now 11. Then what is that going to give us in terms of L1 and L2? Well, we can determine that by putting the wage in to the labor demand equation. So if the wage is 10, 60 minus 3 times 10 will be 30. Or 60 minus 3 times 11 will be 27. So this is operating the way we expected it to. As the wage increased, the labor demand decreased. So what's that going to give us in terms of an own wage elasticity? Again, this is where the wage changes for a type of worker. What do we expect to see in terms of the number of changes of labor units of that same type of worker? Well, as we put this into our change equation, our elasticity equation, we'll use a simple formula. We'll be looking at this as 27 minus 30 divided by 30, and all of that, 11 minus 10 divided by 10. Or we'll see negative 3 divided by 30 equal to 1 divided by 10. Well, that's going to equal, as I simplify this for myself mathematically, that's going to equal the same thing as negative 3 divided by 30 and multiplied by 10 over 1, or negative 30 over 30, which is equal to the absolute value of negative 1. Frankly, it is negative 1. So we would think of this then as unitary elastic, which would suggest that as we have some percent change in the wage, we'll see an exactly similar percent change in the labor unit. Well, that makes sense to us, so it'll be proportionally equal. Well, what does that mean differently than the cross wage elasticity then? The cross wage elasticity, if we have that same market, let's say for the worker, and we've got wage and we've got labor, and we had some downward sloping demand curve. But now we have to think about how is that going to be affecting us with respect to a different worker in a different market. So we have another worker represented by another labor market model. We're also going to have some labor demand, of course. But now, whereas we had originally just a common worker, let's say now that this is really a very skilled worker. We don't know what the relationship is at the moment. We'll explore that in another segment. But we just know that it's a different type of worker. And if, for just our typical worker in the red here, if we have labor demand is equal to 60 minus 3W, but for our more highly skilled worker, let's assume for a moment that we have labor demand is equal to 25 minus 30W. Well, let's see what that's going to do for us. That we probably can't use that. It's not going to give us the kind of value that we need. Let's say it's minus 10W. So now let's see what we might be looking at in this cross wage elasticity equation. Again, this is going to be looking at how the change of wage for one worker, let's say worker J, and let's say that's a skilled worker, how that's going to affect the number of labor units demanded for worker I, let's say that's just the common worker. So we still have to have our L1 and L2, W1 and W2. So let's think of our L1 and L2, or L1 and W1. So we'll have L1, and then we'll have L2, and W1 and W2. But now this is W for the more skilled worker. So let me actually change those to blue so it makes a little bit better sense for us as we're looking at this. We don't confuse ourselves as much. Say W1 and W2. And so let's say that we have our wages for that skilled worker, because we're looking at the wage for worker J, that's our skilled worker. And let's say that this skilled worker began at $30 an hour and is now having a wage increase to $36 an hour. So that's a 20% wage increase. That's pretty significant. What is that going to yield then in terms of a change in these labor units for this lesser skilled workers? Well, we have to consider this in the cross wage environment. So let's assume for a moment that we decided that yielded a decrease in the number of these labor units required, and that we went from, say, the values we had in the prior slide, where we had for the lower skilled worker we had 30 and 27. Let's use those same values, 30 and 27. So we can now create our equation where we have 27 minus 30. This is a simple equation again, divided by 30. And now we'll think about this in respect to the wage of the more highly skilled worker, 36 minus 30 divided by 30. Which is going to then yield for us negative 3 divided by 30 divided by 6 divided by 30. Which, to simplify this for me, negative 3 divided by 30 times 30 divided by 6. Well, this becomes even easier than we thought. We can just cross those out, or negative 3 divided by 6. Or we're looking at this and saying that this would be negative 0.50, which is clearly less than the absolute value of negative 1. So we would say that this is inelastic, which is simply suggesting to us that as the wage for a skilled worker, in this case, higher wages, right? Wage for a skilled worker in this case is increasing, that it's going to bring about an even lower or even lesser proportionate decrease in the number of unskilled workers that we have in the economy. Well, we don't necessarily know what kind of workers these are in this very simplified equation or example. We just know that this worker that is skilled worker J, their change in wage has yielded some change in labor units for worker I, so there must be some relationship. They either have some substitutability or some positive relationship, and we'll discuss and explore that in the next segment.